Welcome to The Explainer. Today we're going to tackle one of the most fascinating puzzles in AI. How do you teach a genius new tricks? Let's explore how we can give an AI the specific knowledge it needs to be truly useful.
Okay, let's just dive right in. Have you ever noticed this? Large language models like ChatGPT are incredible. They can help you write code, plan a vacation, you name it. And yet, 1 second later, they're completely clueless about anything new, anything private, or anything niche.
Ask it who won last year's World Series, and nothing. It's totally in the dark, because its knowledge has a cutoff date. Ask it about your company's internal data, or a very specific coding bug you're working on, or what's in your team's wiki, and you'll get a blank stare. This leads to a really fundamental problem. How do we teach an AI the specific things we need it to know? So what's the first thing you'd probably think of? I mean, the most obvious solution, right? You just copy and paste everything the model needs to know right into the prompt. This is what we call stuffing the context window.
And you know what? For a small document, this actually works surprisingly well. But the second you try to scale it up, you slam into two massive walls. The first is cost. It gets wildly expensive really fast. The second, and maybe even more annoying, is speed.
And here's where you start to see the problem. With a small amount of text, say 1,000 tokens, which are kind of like words, a model is blazing fast. We're talking 10,000 tokens every single second. But look what happens when we blow that context up to 128,000 tokens. The speed just plummets. It crashes down to only 130 tokens per second. That is orders of magnitude slower, and it's because of a core part of the model's architecture called self-attention, which has what's known as quadratic complexity.
But here's the craziest part. It actually gets even worse. Just adding more information can literally make the model dumber. Yeah, you heard that right. It's a known issue called the context broad problem. As you keep stuffing more and more information in, the model's ability to focus on the important bits just degrades. It gets lost in the noise.
So if stuffing the context window is a bust, what's next? Well, that brings us to the industry's favorite solution right now, a really clever technique called RAG, which stands for Retrieval Augmented Generation. The best way to think about RAG is like an open book test for the AI. First, you index your whole library of documents by turning them into these numerical vectors called embeddings. Then, when you ask a question, the system acts like a super fast librarian. It zips through the library, finds the most relevant pages, and gives just those little snippets to the model to help it form an answer. Now, RAG is incredibly popular, and for good reason. You could say it's the file system for LLMs today. But, and this is a really big but, it has some deep fundamental limitations that mean it just can't be the file system of the future. So what's wrong with it? Well, first up, security. Those numerical embeddings aren't as safe as you might think. Research shows you can actually reverse them to get back about 90% of the original text. Ouch. Second, they're not adaptive. They rely on this kind of universal, one-size-fits-all definition of meaning. And third, RAG is pretty bad at deep reasoning that requires connecting ideas across a bunch of different documents. This slide is a perfect example of that not adaptive problem. Let's say you search for information about your Visa card. Well, a standard RAG system might pull up a document about a MasterCard. Why? Because in that universal map of meaning that the model uses, the concepts of Visa and MasterCard are just so similar, so semantically close, that the system gets them confused. This brings us to the real frontier, a newer and honestly much more powerful idea. What if, instead of giving the AI an open book test every single time, we could actually teach it the material so it knows it by heart? What if we could write knowledge directly into the model's brain, into its weights? To get this, you have to understand one thing. These models have a limited amount of brain space. They can only store so much information. The current thinking is it's around 3.6 bits of information for every parameter in the model, and that capacity is finite. So think about that. A huge chunk of that fixed capacity is being wasted on totally useless trivia. I mean, for most business uses, does your AI really need to know the capital of the smallest province in Tajikistan? The goal here is to basically erase that kind of junk knowledge and replace it with the information we actually care about. But of course, there's a huge catch, a massive obstacle that has plagued machine learning for decades. It's called catastrophic forgetting, and it's exactly what it sounds like. When you try to teach a model something new, it has a really strong tendency to just forget the things it already learned. So if just training a model on our documents causes it to forget everything else,
how in the world do we actually teach an AI new information without completely breaking it?
Well, the most obvious way, just training the model on your raw documents, fails. And it fails spectacularly. In one experiment, a model was trained directly on a 3M financial report. When it was later asked to write a poem, it had gotten so fixated on the report's style that it replied, "The passage of a passage is a poem." End of sentence. It just memorizes patterns instead of actually learning concept.
The real solution is powerful and it's pretty counterintuitive: synthetic data generation. So instead of training on our raw documents, we use a powerful model like GPT-4 to read our small set of core documents and then generate thousands of brand new, diverse training examples from them. Things like question-answer pairs, summaries, different ways of phrasing the same idea.
And the results are just stunning. Simple fine-tuning, like we just saw, actually makes the model's performance worse. The base GPT-4 model is a strong baseline. But a smaller model, when it's trained on this rich, synthetic dataset, it doesn't just learn the information, it learns to reason about it so well that it can actually outperform the much bigger GPT-4 on that specific topic. That's a huge deal. And the secret to avoiding that catastrophic forgetting is using what are called parameter-efficient methods. So instead of retraining the entire model, techniques like LoRA, for example, add these tiny trainable modules to the model. This lets us inject new knowledge by only updating a tiny fraction. We're talking less than 1% of the model's total parameters. This preserves all its original skills while adding new ones on top.
So where does this all leave us? Well, we're clearly moving beyond a single, one-size-fits-all approach to AI memory. We're moving into an era where we have a sophisticated, specialized toolkit.
Today, we've basically broken down 3 distinct tools for giving an AI new knowledge. You've got stuffing the context window, which is the quick and dirty method for small one-off tasks. You've got RAG, the industry workhorse, that acts like an open book test for big document libraries. And then you have training into the weights, the future for deep, personalized knowledge, which is like teaching the model to learn the material by heart. The future isn't about choosing just one. It's about combining all 3 in a hybrid approach.
And this brings us to one final, provocative thought. What will the world actually look like when every single person and every company has an AI with a memory that has been custom trained exclusively and perfectly for them?